Hey guys, today's topic is quadratic equation. So let us know what is a quadratic equation first. In polynomials, we saw a polynomial of degree 2 is called quadratic polynomial. So we wrote it as p of x is equal to ax square plus bx plus c is a quadratic polynomial. Now, if we equate this quadratic polynomial with 0, if p of x is equal to 0, that implies ax square plus bx plus c is equal to 0, then it becomes a quadratic equation. Let us have the roots of the quadratic equation. What are the roots of the quadratic equation? So, already we have seen that a quadratic equation or a quadratic polynomial is of degree 2. That means there will be maximum 2 roots. There will be maximum 2 roots of a quadratic equation. It can have one root or no real roots. Let the roots of the quadratic equation be alpha and beta. Then alpha and beta are the 2 roots of the quadratic equation. Then the quadratic equation ax square plus bx plus c will be equal to the form k into x minus alpha into x minus beta. So we have already seen. Then let's come to the solution of a quadratic equation. Solution of a quadratic equation. There are various methods. The first method is by factorization. First method, by factorization. A quadratic equation, a quadratic polynomial ax square plus bx plus c can be factorized as linear polynomials, product of linear polynomials, and ax square plus bx plus c is equal to px plus q into rx plus s. Next, there will be a constant factor along with it. So we get ax square plus bx plus c is equal to p of x px plus q into rx plus s. Taking k as 1, so we get ax plus bx plus c equal to 0, the quadratic equation, we get px plus q into rx plus s is equal to 0. So either px plus q equal to 0 or rx plus s is equal to 0. So this implies x is equal to minus q upon p, or y x is equal to minus s upon r. So we have two roots as alpha is equal to minus q by p and beta is equal to minus s by r. So this is how we solve the quadratic equation by factorization. Let us have an example. Let us solve x squared plus 6x plus 5 equal to 0. Now, to factorize it, we can write as x squared plus 5x plus x plus 5 equal to 0. So we get x common x plus 5 plus 1 common x plus 5, x plus 5 into x plus 1 is equal to 0. So these are the factors: x plus 5 and x plus 1. So x plus 5 into x plus 1 equal to 0. So that implies either x plus 5 equal to 0 or x plus 1 equal to 0. This implies x is equal to minus 5 or x is equal to minus 1. So thus the solution of this is alpha minus 5 and beta minus 1, the two roots of the quadratic equation x squared plus 6x plus 5 equal to 0. Another method is the solution of the quadratic equation by completing the square. Method of completing the square. Let us take the quadratic equation ax squared plus bx plus c equal to 0. In this method, first we make the coefficient of x squared as 1. To make the coefficient of x squared as 1, we have to divide throughout by a. So we get x squared plus b by ax plus c by a equal to 0. Dividing throughout by a. Next, in the next step, we are going to carry out the constant term on the right hand side. So we get x squared plus b by ax is equal to minus c by a. Then we take the square of half of the coefficient of x and add it on both the sides. We take the square of half of the coefficient of x and add on both the sides. So x squared plus b by ax plus the half of b by a is b by 2a and x squared and x squared. So adding here is equal to minus c by a plus b by 2a whole square. So adding b by 2a whole square on both the sides, we get x plus b by 2a whole square is equal to minus c by a plus b square by 4a square. This is what we get. X plus b by 2a whole square is equal to, the LCM here is 4a square, 4a multiplies to 4ac plus b square So we get x plus b by 2a is equal to square, taking onto the other side, or taking square root on both the sides, you get plus or minus under root b square minus 4ac upon 4a square. So finally we get x plus b by 2a is equal to plus or minus under root b square minus 4ac by 2a, or x is equal to plus b by 2a plus b by 2a. Let us carry on this side. It becomes minus b by 2a plus or minus under root b square minus 4ac by 2a. So that implies x is equal to minus b plus or minus root b square minus 4ac by 2a. This is the method of completing the square. Let us have an example and solve it. Let us solve 9x square minus 15x plus 6 equal to 0. So here, first, we have to make the quotient of x square as 1. So let us make it 1 just by dividing 4 by 9. We get x square minus 15 by 9x plus 6 by 9 equal to 0. Or simplifying this, x square minus 5 by 3x plus 2 by 3 is equal to 0. Now sending the constant term onto the right side, we get x square minus 5 by 3x is equal to minus 2 by 3. Okay, now next step में क्या करना है? We have to take the half of the quotient of x and square it and add on both the sides. इसका half लेंगे हम और उसका square लेंगे. X square minus 5 by 3x plus 5 by 6 whole square is equal to minus 2 by 3 plus 5 by 6 whole square. इसका हाफ होगा 5 by 6 और उसका स्क्वायर लेके दोनों तरफ ऐड करें. Then after that उसके बाद यह हो जाएगा x minus 5 by 6 whole square is equal to minus 2 by 3 plus 25 by 36. So that implies, अब ये perfect square हो गया. X minus 5 by 6 whole square is equal to LCM 36. 12 will be multiplied minus 24 plus 25. We get x minus 5 by 6 whole square is equal to 1 by 36. That implies x minus 5 by 6 is equal to taking root plus or minus 1 by 6. Square root of 1 by 36 is 1 by 6. Plus or minus 1 by 6. Taking plus value, x minus 5 by 6 is equal to 1 by 6, or x minus 5 by 6 is equal to minus 1 by 6. So from this we get x is equal to 1 plus 5, 6 by 6, or x is equal to 1, or x is equal to minus 1 plus 5 by 6, so x is equal to 4 by 6 is equal to 2 by 3. So the solution is alpha equal to 1 and beta equal to 2 by 3. So this is how we solve by method of completing the square. We got the perfect square here and we have solved. The next method is the Sridharacharya's method, that is using the quadratic formula. using directly the quadratic formula. Third one, using quadratic formula. Also known as Sridharacharya's rule. So, if ax square plus bx plus c equal to 0 is the quadratic equation, then and d is equal to b square minus 4ac, then alpha will be equal to minus b plus root d by 2a, and beta will be equal to minus b minus root d by 2a, where d is the discriminant, it is equal to b square minus 4ac. If nature of roots, let's come to if the discriminant d is greater than 0, then there are two distinct roots, two real and distinct roots. If the discriminant d, the value of discriminant d is greater than 0, then there are two real and distinct roots, and they are alpha is equal to minus b plus root d by 2a, and beta is equal to minus b minus root d by 2a. Here are the two distinct roots. Secondly, if d is equal to 0, then the roots are real and equal. The roots are real and equal. That is, alpha is equal to beta is equal to minus e by 2a. Thirdly, if d is less than 0, then we conclude that there are no real roots. So this comes under the nature of roots. If d is greater than 0, then there will be two real and distinct roots, alpha and beta, with this formula. Then if d is equal to 0, then d becomes 0, then the roots are equal, both the roots are equal. So alpha equal to beta equal to minus b by 2a, and if d is less than 0, there are no real roots. Let us solve a question, quadratic equation, by using quadratic formula. Let us solve the quadratic equation 9x square minus 15x plus 6 equal to 0 by using the quadratic formula. Here a is equal to 9, b is equal to minus 15, and c is equal to 6. Then let's find out d. D is equal to under root b square minus 4ac, that is equal to under root minus 15 whole square minus 4 into 9 into 6, that is equal to under root 2 to 5 minus 216. That is equal to under root, we get 9, and that is equal to 3. So D is equal to 3. Now D is equal to 3, that means D is greater than 0. So there are two real and distinct roots. There are two real and distinct roots, and they are alpha is equal to minus b plus root d by 2a, and beta is equal to minus b minus root d by 2a. So this is equal to minus of minus 15 plus root 3 by 2a. 2 into a, 9. So we get that is equal to minus of minus 15, 15 plus root 3 by 2a, that is 18. And that b equal to b square minus 4ac. Sorry, we have taken the root here. It is equal to 9. D is 9. So here we get 9, square root of 9. Square root of 9 is 3. So we get 15 plus 3 by 18, that is equal to 1. Then here again beta is equal to minus of minus 15 minus root 9 by 2 into 9. So that is equal to 15 minus 3 upon 18. That is 12 upon 18. That is equal to 2 upon 3. So the roots are alpha is equal to 1 and beta is equal to 2 upon 3. Are the two roots using the Sridhar-Acharya's rule or the quadratic formula. Now let us have the conditions for common roots. Conditions for common roots. If a1x square plus b1x plus c1 is equal to 0 and a2x square plus b2x plus c2 equal to 0 are the two quadratic equations, and if c1a2 minus c2a1 whole square is equal to b1c2 minus b2c1 into c1a2 minus c2a1, then the two quadratic equations will have a common root. Will have a common root. Thus, to have a common root, the condition is c1a2 minus c2a1 whole square is equal to b1c2 in minus b2c1 into c1a2 minus c2a1. Second, if a1 A1 by A2 equal to B1 by B2 equal to C1 by C2. Then the quadratic equations, then both the roots of the quadratic equations are common. So we have one root common. The condition is C1A2 minus C2A1 whole square is equal to B1C2 minus B2C1 into C1A2 minus C2A1 for one root common. If both the roots are common, then the condition is A1 by A2 equal to B1 by B2 equal to C1 by C2. So with that, we complete the revision for quadratic equations. Let us go for probability. Yes, as we know, probability is just a chance or just a possibility of happening something. So, if we consider a question that if it rains today, so what is the probability of it raining today? You will say it is 0 because it's totally a clear sky and the probability of raining is 0. So the chance of raining is 0. In the same way, we have like the first term, experiment. Now probability we find by conducting experiment. Like suppose we want the probability of turning a head in tossing a coin. Now tossing a coin is an experiment. Just tossing a coin is an experiment. Okay. Once I have tossed the coin and it turned up head. Second time again I tossed the coin. It turned up tail. Again I took and tossed the coin. It may turn up again tail. The fourth time again I toss the coin, it may turn up as head. So, all these activities, that is the activity is tossing a coin is an experiment. The activity performed with many trials is called an experiment. The outcomes, turning up head, turning up tail when tossing a coin, they are considered as outcomes. It is the result of a trial of an experiment. The result of a trial in an experiment is called the outcome or event. This is called the outcome or the event, denoted by E. The favorable outcomes. Favorable outcomes. Now, the outcome becomes favorable if it is desired. The outcome which we need to occur is called favorable outcome. Okay, so the desirable result of a trial by performing an experiment is called favorable outcome. Example: tossing a coin is an experiment. Tossing a coin is an experiment. Turning up head in the first toss is an outcome or event, and if we want the tails to turn up, then so the desirable result is tails, then it is the favorable outcome. So this we have experiment, trial, outcome and favorable outcomes. Then probability of an happening an event is denoted by P of E. Probability of happening an event is denoted by P of E, and probability of not happening the event is denoted by P of not E. P of not E. And the total number of outcomes in an experiment is the set of sample space. The set of total number of outcomes, you can say. The set of total number of outcomes in an experiment is called sample space. Which is denoted by S. Thus, we can write the probability of happening an event we can say that probability of happening an event is equal to the number of favorable outcomes by the total number of outcomes. So we can write probability of happening an event P of E is equal to number of favorable outcomes total number of outcomes. Total number of all possible outcomes. So that is equal to n of E by n of S. So this gives you the probability of happening an event. So probability of happening an event is equal to number of favorable outcomes by total number of possible outcomes. Also, P of E, probability of happening an event, plus probability of not happening an event is equal to 1. So the sum of the probability of happening an event and the probability of not happening an event is 1. Also, and probability of happening an event is always less than or equal to 1 and greater than or equal to 0. It cannot be greater than 1. Also, we know that probability of a sure event sure or certain event is 1. Sure event is the event which is going to take place. So probability of a sure or certain event is 1. And probability of an impossible event is 0. The probability of an event which is not going to take place or which is an impossible event is 0. So we got. So let us have some examples of probabilities. Let us have example of tossing a coin. Experiment is tossing a coin. Then, if we toss a coin, there are only two possible outcomes. That is head or tail. So, the sample space is equal to head, tail. So, the number of total possible outcomes is equal to 2. Tossing 2 coins. Tossing 2 coins at the same time or simultaneously. If you toss 2 coins at the same time, then what are the possible outcomes? It can be head on one, head on another. It can be head on the first tossing and the tail on the second. And in the same way, you'll have different outcomes: HH, HT, TH, TT. So these are the possible outcomes. So number of possible outcomes is 4. Then these are all tossing of the coin. Then we can toss or throw a die. Another experiment, throwing a die. If we throw a die, the possibilities are turning up 1, 2, 3, 4, or 6. So S is equal to 1, 2, 3, 4, 5, 6. The number of possible outcomes is 6. If you are asked a question on the die, what is the probability that it is a even number? Probability of even number. throwing an even number. So that will be equal to, we just choose out how many even numbers, 2, 4 and 6. That means the number of favorable outcomes is 3 and total number of outcomes is 6, and that is equal to 1 upon 2. Suppose we throw 2 dice together. Throwing 2 dice simultaneously. If we throw 2 dice simultaneously, in that case, what are the possible outcomes? So the sample space will be 1 on the first die, 1 on the second die, 1, 2, 1, 3, 1, 4, 1, 5, 2 on the first, 1 on the second, 2, 2, 3, and in the same way it can be up to 6, 6, 6, 5, so on. So we find that number of such total possible outcomes will be equal to 36. So total number of outcomes when 2 dice are thrown simultaneously is 36. If you are asked to find out the probability of a doublet, of getting the same number on both the dice, then probability of getting a doublet will be equal to, now you should choose, the doublet is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6. So there are 6 favorable outcomes out of total 36. So that is equal to getting a doublet, probability of getting a doublet is 1 by 6. So like that you can answer so many questions based on 2 dice thrown simultaneously. Then another experiment is cards, playing cards. Playing cards. Now we know that playing cards, there are 52 cards in a deck of playing cards. So in total there are 52 cards in a deck of 52 cards in a deck of playing cards. Now in these 52 cards there are 2 colors, red and black. 26 red colors and 26 black colors. So 52 cards is equal to 26 red plus 26 black. There are 3 face cards. There are 3 face cards, that is J, K and Q, and there is an ace, one ace card, and there are 9 number cards. Two, 3, 4, 10. There are 9 number cards, 1 ace card and 3 face cards in one color. So if we draw the table, 52 cards, let us understand through a table, is divided into 26 cards, 26 red cards and 26 black cards. Then this 26 red card is further divided into 13 and 13. This 13 is diamond and this 13 is heart. And hearts. Here, this 13 and this 13, the black first is spades. Don't know what you call it, spades. It will be like this. You will identify with the bigger spades and 13 clubs. That will be like this. Then each 13 cards will have one ace, one ace card, then 3 face cards, J, K, Q, 3 face cards, and 9 number cards, 2, 3, 4, up to 10. 9 number cards. In the same way, you have this 13 as 1 ace, 3 face cards, and 9 number cards, and same way those ones. So, like that, this is the table through which you will identify the 52 cards and how they are arranged of the different colors. Thank you all of you. With this, we complete today's talk.